Technology permeates our daily lives. It is always important to think about what technology should do instead of what it can do. I'm Richard Koh, and welcome to our Tech 101 with our technology strategist. Hi everyone, welcome to another episode of Tech 101 with our cloud solution architects. Today we have Akash Kumar. He's one of our prolific CSAs who is very good with containers, and as you know, containers has taken the cloud services world by storm, and it's really helping a lot of our developers and engineers reimagine how they can really leverage containers to be able to optimize their applications. And today, with Akash here, who really has a passion around all the Azure offerings that we have around containers itself, I'm going to be asking him to talk about some of these offerings that we have on Azure itself and really show you a couple of demos that he will go into detail in this particular episode on each one of them. So Akash, welcome to the show. And why not you just let the audience know, introduce yourself and what you do on a day-to-day basis.
Yeah, thank you, Richard, for inviting me for Tech 101. Yes, I'm a cloud solution architect. I've been supporting here some of the digital native based out of Southeast Asia. Containers definitely have been like a buzzword in the market, but the most important thing, it is solving some critical business problems. And in today's session, I will be covering some of those business problems with some of the offerings what we have from our Azure Container Service offering side.
And you know what? I learned a lot from Akash when I think about containers and how it has been able to abstract away, the operating systems and things like that, as opposed to the, let's say, traditional virtual machine type of stuff. I thought it was like, oh, this is a great, advancement and development in the cloud services world itself. So Akash, for today, what are the different, let's say, Azure containers offerings that you are going to touch base on?
Yeah, in today's session, we will be talking about the flagship Azure Kubernetes services. Mm-hmm. We will be talking about Azure Container Instances, which is a quite unique offering what we offer compared to many other available solutions in the market. And the last, we will be covering about the latest offering what we have called Azure Container Apps.
Wow, okay, so this is really amazing. Azure Kubernetes Service, Azure Containers Instances, as well as Azure Container Apps itself. And each one of these have, I would say, different kind of usage scenarios, right? So maybe you might want to just quickly bring us through each one of them, and then we'll dive into the demo.
Sure. So let's start with the AKS, which is Azure Kubernetes Services. So Kubernetes is a buzzword. Everybody is heading toward it. I don't think people are nowadays deploying application as a VM. Everybody wants to deploy application as a microservices, and Kubernetes solve the purpose. Now, the thing is, if you want to build your own Kubernetes environment, it's a massive task. So therefore, we have come up with a complete managed offering for organizations. You don't build the entire control plane, we will be managing it for you. What you focus is on pure play in managing the cluster and the nodes, and the building the microservices and pushing those microservices to your cluster. We will be still giving you the control as well as the API access so that you can manage the Kubernetes environment, but the entire backend is managed by us. So that's one of the first and flagship offering, but we have it.
Okay, that's great. So while Microsoft's help with some of the management part of it, we still maintain that kind of flexibility that engineers and developers are looking for in terms of managing their container nodes, for example.
Exactly. And on top of that, you will also have a flexibility to build in your own cloud native foundation tools such as SCADA. You want to bring your own proxies like Envoy. You want to have additional security layers like where you want to have a sidecar containers doing a kind of a image, taking a logs and processing somewhere else. All those flexibilities and capabilities you get it with AKS. And that is one of the demo which I'll be covering in my first scenario, wherein I will show you as in how in AKS running in my cluster, I'm going to invoke the pod scaling using SCADA. SCADA is one of the prominent CNCF tool which basically helps organization to trigger pod scaling basis upon event. And we are not talking about event as in CPU or memory. We are talking about event as in business events. It can be as in something like queues are coming in my Redis cache, just increase the pods, process the queue, empty the queue, and once it is done, bring back to the zero pod. So what is happening in this entire process? We are not doing anything. The entire integration of KDA with AKS is happening, and it's managing the entire scaling and scaling down. And the most important part, we are avoiding the wastage of resources, because once you bring down to zero, the entire node is available to you to the rest of the other job.
Okay, and this is all business-driven type of setup.
Yep.
Okay, so let's do this. We'll put aside Azure Container Instances as well as Azure Container Apps for now. Let's go see the demo for Azure Kubernetes Service, shall we?
Sure. Let's have a
All
demo.
right, let's go.
In this quick demonstration, I will show you how Azure Kubernetes services can work alongside KDA-like solutions to perform event-based triggering. In my demonstration, I am going to have external data source, which is Azure Cache for Redis, wherein I have a list and the list will have an element. KDA will basically work alongside horizontal pod scaler, which is a native scaling offered by AKS, and KDA will basically review any trigger happening on the Azure Cache for Redis. If there are any new elements getting created, KDA will detect it, and KDA will basically tell horizontal pod scaler to create and delete the pods basis upon the length of the elements inside the Redis. So let's get going. I have a cluster running already, so this is my cluster. I have enabled already my KDA inside my cluster. So if I show you, you can enable KDA inside your cluster using Helm. You can deploy it manually, or you can enable it as a manage add-on preview, which we have already released. With this, I'm going to deploy my application, which is a simple application, which is here. And this application, I'm basically creating a Redis client, providing a resource limit around CPU memory, and obviously providing the Redis environment variables. With this, if I see, the pod quantity should be 1, because as of now I have not deployed the scaling object, which is a KDA manifest. So with this, I will be deploying KDA manifest, which is where I'm defining the minimum and the maximum replica count, which is 0 minimum and the maximum is 20. I'm defining the other parameters such as cooldown period. I'm also defining the horizontal pod scaler configurations, and the most importantly, I'm defining what trigger will it triggers the horizontal pod scaler, which is my Redis. So with that, I'm going to create a scale object. It is already enabled. With this, if I go to the pod quantity should become 0, which was earlier 1 in my initial deployment here. Now what I'm going to do, I'm going to create a element and the list inside my Redis so that I start creating stuff. So I have done that. I'm going to create one more time, and if I go and do that, this is 600 quantity length. So with this, if I go inside pod, you would notice the pods starting spawning up. This is all happening basis upon my scale object, and the scale object is triggering horizontal pod scaler, and horizontal pod scaler is basically creating the pods, and the pods are consuming these data sources. So if I go inside my data source, you would gradually start seeing the quantities getting reduced. So this is a perfect example how a cloud native application can be built on Azure Kubernetes Services, and you can use your favorite cloud native tools to perform and customize your entire deployment experience. You can notice my replica count is reaching to the max, and if I go inside my pods, you would see they are doing their job, and once the job is finished on those particular pod, they should basically get terminated and free up the resources. This is also one of the reasons why such event-based scaling comes handy, because you are utilizing the resources of your computer location to the maximum possibilities. Since the job is done, you would notice my pods are getting automatically terminated, and they are basically freeing up the resources. So if I go inside my current replica sets, so we will have a no, it is back to 0, and if I go see pod, there are no pod. So we are done with the demo for KDA and with AKS.
Oh gosh, that was a great demo. I'm just quite amazed by it. So how do you do all this integration?
So in this demo particularly, I use the manual way of like installing the HECADA inside my cluster. But the good part is that you can install HECADA using Helm. And the best part is that we have a managed add-on available for the AKS. So which basically means the HECADA is having now deeper integration, and even AKS is going to engineering team is going to support it.
Okay.
So it's already in preview. You don't even wanna install manually. You don't want to go through Helm route. No worries. Just run one command. AKS enable add-on HECADA. That's it. It will install it.
I like it. It's choices for our developers and the engineers community.
Yep.
So this is really cool. Okay, let's talk about the second demo that you have. This is another exciting one, the Azure Container Instances itself. So tell us a little bit more about that.
Yeah, so as you have seen the AKS side of the thing, we still have a lot of things to be managed from the infra side of the thing, networking side of the thing, security, configuration. There are a lot of times companies comes with a requirement that, hey, I want just container to be pushed to environment. That's it. I don't need to worry about what is under the hood and all those things. For me, I'm just going to give you container file or a registry. That's it, and rest you run it and process my job and come back. So if you hear it, the keyword here is like job kind of workloads. If you are looking towards like not a long, like a stateless kind of workload or a typical non-enterprise workloads, right? And the most important part, if you are looking for a pod but with a hypervisor level isolation, ACI is the workload, is an offering, you should go for it. In my demo, what I'm going to show you is that, let's take an example of a organization. I want to host an API, but this API is going to be accessed only via privately, right? Which basically means this API will be connecting to some backend, which is a database and not available to the internet, but I'm hosting it as a container. I'm not interested in managing entire backend of the things. So how do I do that? So in this demo, what I'm doing I'm basically putting a two-way approach kind of things, wherein I'm putting a sidecar with the Nginx, which we will connect to sidecar, and sidecar will act as a proxy to talk to the main worker, and the main worker will talk to the backend. So in the demo, what you would see, I'm not able to connect to the API publicly. Secondly, I'm not able to connect API also directly, even privately, because sidecar is front-ending it. And when you will see the logs, actually in logs you can see the logs are clearly showing that sidecar is telling me that request coming from my SSH VM, but the core worker node, which is run, the core worker container will show you that request coming from the local host. So in this point of time, it's like a super secure deployment in a VNet, in a private nature. I'm not exposing it to the internet and still doing the job, and I'm not managing any node, pod and all those things. It's just my container and pod, that's it.
Yeah, sounds really cool, because there's some sense of security and dedication to what kind of host is calling it and stuff like that.
Yep.
Very exciting. Shall we go see the demo?
Yes, let's see the demo.
In the next demo, I shall be quickly taking you through another container offering by Azure called Azure Container Instances. Azure Container Instances is a great solution for any scenario that can operate in isolated containers, including simple applications, task automation, build jobs. It provides hypervisor level security as it would be in a VM, customized scenario, pay for the consumption up to per second billing. It offers persistent storage. It also offers Windows and Linux container, and most important, in an enterprise scenario, it offers core schedule groups, which is multi-container and sometimes called sidecar deployment patterns. At the same time, it also offers virtual network integration. The demo I will be taking you through, I shall show you how a sidecar container can be easily deployed in a ACI and consume a private API which is not publicly exposed, and retrieving a database data details from the backend. As you can see, I've already deployed my base environment, which is my SSH VM with the VM through which I will enter the environment. I have my database running with the private endpoint and the DNS zone mapping, and the VNet is already there for the ACI. And if I go inside my VNet, I should have a subnet delegation already defined for ACI. So let's deploy ACI. Before that, I want to check if my resolution is happening. So if I go inside VM and try to resolve to my database FQDN, you would notice it is resolving to the private link and I'm getting the private IP because I'm going to the VM. Before I deploy my sidecar container and the main container API, I have already created an SSL self-signed certificate key and certificate. I'm going to create an Nginx configuration and bind the SSL cert and keys. I'll do the encoding and then I will create a YAML file for the deployment. As you can notice, the YAML file for the ACI and the Kubernetes YAML are quite similar apart from API changes. So if you are an organization who is familiar with Kubernetes, you should not have a challenges in terms of learning and adopting ACI quickly. So I have YAML created for my ACI. Let's get it deployed. While the deployment is going on, you would notice in that ACI of a ACI name, I'm basically deploying two containers. One is a Nginx and I'm deploying the second one is a SQL API. And my certificates and the keys are already binded to the mount path which is there. And similarly, I'm also binding the secrets for variables for my SQL Server environment. So my containers are deployed. Let's fetch the IP of my ACI. So since I have deployed my ACI in the network, it should be responding back with a private IP. And how do I know that it is getting deployed? If you would have noticed here, I've already defined subnet resource ID inside my YAML configuration. So I already have the IP. So let's do SSH to my VM through which I'm going to reach out to the side container, which is nothing but a proxy, to reach out to the private API, which will return my data value from my database. So let's do the first health check. So here it is giving me OK. Let me go back to the database now. There you go. So I'm reaching out the database is responding back with the database details and the private IP associated to the private endpoint. I want to know the database version, and all this work is going to happen through proxy to the private API via private communication. And the last request, I will check it out, the output. Now in this demonstration, as you would have seen how through the SSH coming through internet, we have reached to the proxy, which is sidecar container, and through the sidecar container we are reaching it out the private API, and the private API talking to the database or private endpoint. How do I prove that as in how the communication is following? So let's go and do the logs check for the sidecar proxy. So this is my sidecar proxy. As you would have seen, these are the requests I just made few minutes back. You can see they are being reached out. And if I go inside my API container, you should be seeing the local host, which is 127.0.0.1, because the requests are not coming directly from my SSH VM, it is coming via proxy. So for me directly to reaching to the API is not feasible. I only can go through the sidecar container. The same logs are available on the portals. If you go inside my ACI container instance, you would see those two containers running, and the same logs are available here. You can see the health check coming from 1.4, and the Nginx, which is talking through the local host to this API, is coming through this. So this is what I wanted to show you quickly, the power of ACI, which can address the specific scenarios in your requirement.
Wow, Akash, that was a great demo itself. I noticed that you were using Visual Studio Code Space to look at some of the logs. Can you tell the audience a little bit more what you're looking at?
Yeah, so this entire demo was hosted in a GitHub, and I'm using the GitHub code space, and I'm using the code space directly to my local Visual Studio Code. So yes, I was running a simple script for logging of the ACI container, and it's just one CLI command. And the best part is that the output is same as you view it in the terminal in the code space or a local CLI, or even going to the web UI, which I showed in the demo.
Okay, wow, so this is really cool. Okay, I know we have a third one. I'm sure the audience is all waiting for it, and that's around Azure Container Apps itself. So it's a fairly new offering.
Yeah, it's a quite new offering, and so in a simplest word, it's basically serverless container service. Why basically you are not going to manage anything in this basically under the hood. Unlike in AKS, we have to manage nodes, we need to manage like node groups, all those things. In ACI, we need to still manage something, but here you are a developer, your code, that's it. Rest other things is nothing matter, because you're just pushing it to your ACA, and the ACA is basically doing entire provisioning stuff and everything.
Okay, so my business apps just have to call it, boom, that's it.
Yeah, your business developer just need to focus on the code development part and the development lifecycle. They can bake it everything the way I have done in my demo. What I've done it, I have 4 microservices in 4 folders. I have also injected my monitoring together, and I have injected my provisioning together as a bicep, and I'm just doing a commit of deploy branch, and the deploy branch is triggering my GitHub action. That's it. And once it is done, after 5-10 minutes, my environment is up and running with all those gRPC stream coming from worker node to the service, and service is giving it to the front end.
Okay, nice. So you're triggering it for GitHub.
Yeah, the GitHub is the codes repository. I'm using the GitHub action for doing the entire continuous deployment, and obviously I'm also using the GitHub agents to do the job in terms of processing the things build up, because there is a build part also.
Got it. Wow, sounds exciting. We should go see the demo. Let's go.
In the last demonstration, I shall cover about the latest offering around container called Azure Container App, which is also referred as ACA. ACA provides fully managed serverless container services for deploying modern application at scale. In a simplest word, is a platform as a services for container, where developers just focus on developing code, package it into the container and push it to the ACA. Rest, it will take care of it. Unlike in AKS, where you have a deeper control and customization capability, you have access to the Kubernetes API, yet you need to manage environment, server nodes. In ACA, you are not going to have access to the Kubernetes API. You don't need to manage environment. We will be managing it for you. So same thing I'm going to demonstrate. The repo has basically 3 applications, which is nothing but a microservices front-end application running a Blazor server. The services, which is basically gRPC host, it is basically .NET gRPC. It is going to consume gRPC requests from the worker nodes and send the stream back to the front end for a visualization. So my internet is going to hit front end. The front end will basically be provided gRPC stream from services, and services is getting requests from the worker nodes. So all of them are basically being created as an application separately. They have their own APIs created and been composed as a Docker files in respective folders. We have also baked in the provisioning code as in biceps in the folders, and all the code together, including the monitoring pack integration, we have done it together and put it as a workflow. So what I'm going to do it, I'm going to perform a commit on my repos here, and based on that commit, my GitHub should tick it up and perform that action, which basically a workflow. I'm going to use deploy as a branch. The moment I use this, the action should pick it up, you can see. And the action is basically first is doing a provisioning. After provisioning is going to build that environment. Environment basically means the image Docker file will basically be uploaded and to the container registry, and the last is basically the deployment of application inside that ACA. So my provisioning is done. Now the build job is going on, wherein we are basically Docker build process. We are logging into the ACR. We are building service image, pushing to the ACR. We are at the last part of the workflow. We are really this time checking it out branch, basically installing the extension, logging into the ACR, and then basically pushing the code inside the container apps. You would see my container apps is up and running. What is missing it out is just showing the default web page. In a few minutes or a second, it should basically be updated with the code. you would be noticing here the workloads are already running. I have a container registries, and the repository has respective APIs, front-end service and worker. These are the container apps. Each microservice is running in a container app inside a container app environment. So we are done from 0 to 9 minutes 38 seconds, from a repository to the provisioning to the building of image, everything we are up and running. And if I go inside the front end page, you would be able to see it's basically showing a line which basically fluctuates as it receives the data from a gRPC APIs. So let's make some changes and see how does it work. And you can notice the worker is 109, is basically the one. And what we are going to do, we are going to revision this worker and we are going to increase the quantity. So we go to the worker, we have selected it already. We go next, we are going to increase it to the count, let's say 4, and boom. So we should start seeing it, the pages get updated with the more lines coming from the different workers. And here you go. So my first worker, my second worker is ops, third and fourth. So we can see the things are working perfectly fine, and we can go inside the log analytic workspace as well as and go and run the logs and see what kind of logs are getting generated. As you can see, the sensor is sending data, and if I expand this, you should be able to see the time it generated, the kind of a data it has sent, all the information that's getting generated. You can see this is basically come from Q7, and you should see some Q0 also. At the same time, if I go and look into my more insights, so if I go inside my application map, you can also see the information getting populated also here, as in one instance is basically calling front end, which is fine because I'm already connected to the web page. And you can see there are total 5 instances working in the worker, and there is one instance for the sensor. And you can see the requests going from sensor worker to the sensor services, what all information, everything is fine grained and control, and you can see all the information getting populated and see. So this was quick demonstration, basically a sample walkthrough wherein you were able to create a distributed cloud ready application running on a cloud Azure Container App, which was making use of gRPC in terms of both request and response and streaming APIs. You have also seen how to monitor and view the application logs. As you can see, I'm reviewing the live metrics inside application insight. So if you wanna play around on this, we have a good amount of sample applications available for Azure Container Apps on Azure Docs. Go there, play around it, and utilize it for your organization benefit. Thank you.
Akash, that was a great demo again. So I noticed that you were doing some of that event kind of driven type of scaling and also looking at some telemetry. Can you give us a little bit more color on that?
Yeah, so initially, if you would have seen, I changed the revision from 1 to 4. Basically, what I was doing, I was scaling it manually. This can be done automated way. And yes, so that was, I didn't do anything like in terms of choosing the configuration type, if you notice, right? I just increased the quantity. That was another thing. And even as a developer, I'm more focused on terms of the environment, telemetry, logs, how my API tracking to each other, what are the requests, what are the delays. So in application inside, I was going there because I didn't provision it manually. Everything went there, pushed it as a code bundle together to the ACA.
Okay. And then the telemetry side, and what other information does, let's say, for example, an engineer like yourself would look for?
Yes, absolutely. When the things goes wrong, what we need is where the things goes wrong. That's where application insight comes helpful, because it's not just it's application logs.
Right.
which API request, GET request, and which particular part is taking most time and which is the error. That's where it can help us, give us a real micro pointers like to focus upon that. This is the area where my calls are giving me 404 while the rest is giving me 200.
Right.
So application insight is it's the core. If in case you are really into the developer centric approach, then ideally you should make it all code together. And when you push it to the ACA along with application insight, so that you can do a complete tracing, debugging, and even the profiling also.
Yes, it's great for troubleshooting.
Yeah.
I love it that way. Okay, so this is great. I mean, wow, we went through a lot in terms of all the Azure containers type of offerings itself. I know we haven't been able to show you everything, but Akash, I know you're really steep into this space. What other kind of offerings from Azure do we have around in this space?
Yeah, so we only talk about the major three things.
Yeah.
We actually have few more offerings. So if in case you're an organization who is having your own Red Hat OpenShift kind of environment, we have actually co-engineered containers offerings called Azure Red Hat OpenShift, which is jointly built together, offered it to you as a first party. Second thing, if you are majorly into the Java side of the world, Spring Apps kind of things, we have Azure Spring App. Azure Spring App is quite similar to ACA, but it's predominantly meant for Java workload. And the last, which is Evergreen, we have heard about App Services. App Services actually also offer available wherein you can spin up this web hosting as a container and a backend.
Okay.
So you can actually go there and position it and use your registry to spin up your environment.
Oh, very cool, very cool. Yes, I remember Red Hat OpenShift. If you're still hosting it on-prem, this is the way to move it over to Azure.
Yep.
Okay, that's great. So, everyone, I hope you enjoyed this episode. It's been such a great learning experience for me on all the Azure containers offerings, and I hope that you will have a chance to look at all of this and explore them and use them in your environment itself. So Akash, last question. If our audience wants to find out more about this, where should they go?
Yes, you can go to this link to learn more about Kubernetes services, the container offerings we have it.
All right, very cool. So thank you very much for coming on to the show.
Thank you, Richard.
And thank you so much for watching this episode, and we'll see you next time. Thank you.